Farmers and agricultural organization leaders know the Mississippi alluvial plains aquifer has been declining in places. But they don't always know by how much or what economic impact the decline might have. The U.S. Geological Survey's MAP project is attempting to find answers, as Dr. J.R. Rigby explained in a presentation to the virtual Arkansas Soil and Water Education Conference.
Part of the emphasis for MAP was always to try to bring in economics to the picture. Our economics team has put out a fact sheet on the economic impact of groundwater and agriculture in the region. As we're moving towards the end of the first phase of MAP, where we're trying to incorporate all of these components into decision support, they're also working on cost function models for groundwater and for surface water groundwater partitioning. And they're also looking at developing relations for regional evaluation of groundwater decline. The goal here is when we see model forecasts for 1 foot or 10 feet of model decline in the long term, what's the economic impact of that to the region, at least our forecasted impact to the region. I think that'll help regional decision makers with tough decisions down the road if they see what the economic impact is likely to be. And then part of that is developing more sophisticated forecasting capabilities. In the past, we would just take whatever the final year in the data was and extend that year into the future when it came to drivers like the crop distribution on the landscape. Our economics team is working to use crop commodity forecasts that come from USDA that go out 1 or 2 decades and use those commodity forecasts to better represent what the likely changes in crop distributions on the landscape will be, and we'll build those into our forecasts in the future. And finally, in terms of what we're working towards on the data side, we want to do network optimization. This is something that's been on our minds with the MAP for several years. We're getting to the point now where the models are mature enough to help us with network optimization. But rather than looking at the MAP as a one-time study that puts out a model that's then used and likely obsolete in a short amount of time, we want to use the models and the insight that we've gained to design long-term data collection networks that are going to feed the model and improve the model over the long term. So instead of MAP coming and then going away, the idea is that we finish this first phase of MAP, and that ends with a set of data collection networks that have been either reconfigured if we have all the infrastructure we need, we just might need it in different places, or that we've added to it where we need additional data to really help make decisions in the future. And this extends to groundwater level monitoring, as well as water use, and even to some ET network monitoring that we're getting into. And all this culminates with our decision support component. Decision support means a lot of things depending on who you talk to. From my point of view, what we're trying to do is combine 3 pillars: data access, integration, and scenario support to provide information to decision makers. For data access, I mean we want all of our data to be available at a single stop. So in this case, a web interface where you can go and see all of the USGS data sets that are being collected and aggregated into the MAP. And if you want to know where water use is being collected real time, you can go to that website, find the real-time water use network, and look at the data from that site. Integration means that we're taking all of the available data and not just handing you the data, but integrating that data into something that takes into account all of the implications of the data sets. Usually that means models. So we're doing the background modeling to integrate all of those different data sources. And then with those models, we're providing scenario support. I think it's important if we're trying to make decisions, not just to define a single optimal path or to tell you where you are now, but to give you some idea of, based on which choice you make, how bad will things get or how good will things get. So providing scenario support based on where we are now, updating that hopefully on an annual basis, so that each year when we're making regional decisions, we can see how last year's decisions factored into the current situation. And then scenarios ideally should show a range of possibilities. We should show more sophisticated scenarios for weather and climate, and show, for example, a dry, wet, and normal scenario going forward, and what's the implication for each of those for a 5-year, 10-year, or 20-year horizon.